You're miles from home, and your electric scooter interface blinks red and goes completely dark. You check your bag, but your charger is missing. The immediate temptation is to grab any nearby power cord that happens to fit the charging port and force some life back into the machine. But lithium-ion batteries are cylinders of controlled chemical energy. Forcing the wrong current inside causes temperatures to spike, triggering thermal runaway. To prevent this, your scooter's battery management system acts as a strict gatekeeper, blocking mismatched power to protect the cells. Bypassing your original charger is possible, but you have to act as a temporary electrical engineer. You must perfectly manipulate voltage, current, and polarity to safely revive your scooter. The safest workaround is using a universal power adapter. These devices take standard alternating current from a wall outlet and convert it into the direct current your scooter requires. To use one safely, the adapter's output voltage must match your scooter's required input exactly. Next, check the current. Your adapter's amp rating must be equal to or lower than your original charger to avoid overloading the system. You also need the physical hardware to match. Electric scooters use specific connectors, like 3-pin XLR or coaxial plugs, so the adapter must have the correct interchangeable tip. Finally, you have to align the positive and negative pins correctly. Reversing the polarity will instantly fry your scooter's circuit board. Universal adapters offer a reliable solution when you are stranded, provided you adhere strictly to these electrical specifications to prevent irreversible hardware death. If you are stuck outdoors without a wall outlet, you might look to portable power. But standard phone power banks will not work. You need a high-capacity portable power station with a dedicated DC output. We can see exactly why by looking at this comparative bar chart measuring watt-hours, the metric for total stored energy. A standard scooter battery holds around 480 watt-hours, completely dwarfing the tiny 55 watt-hour capacity of a typical mobile power bank. To charge from a station, route the energy through its DC output and verify that the voltage perfectly matches your scooter's input requirements. Keep your expectations realistic. Transferring energy this way incurs heavy conversion losses, meaning charging will be slow and you will not get a full battery. Think of portable power stations as emergency life rafts. They will get you a few extra miles down the road, but they cannot fully replenish your scooter. If you have access to a workshop, you can bypass consumer electronics entirely using a laboratory-grade variable DC power supply. This method requires extreme precision. Before you even touch the scooter, you must manually dial in the exact end charging voltage on the supply interface. You also have to calculate a safe charging current. A reliable rule is to set the dial to output no more than 20% of your battery's total capacity. Without specialized lab equipment to control the flow, desperate riders often improvise raw power sources. Take a car jump starter. This schematic shows why using one is a fatal error. Jump starters dumped hundreds of amps instantaneously. When that massive wave hits the thin wiring of a scooter, the wire immediately glows white-hot and snaps. Wiring power tool batteries together in series carries the same risk. It bypasses the scooter's safety limits entirely, leaving you with zero control over the current. Manipulating raw electrical power is a high-wire act. Ignoring a single variable, even for a second, results in the immediate destruction of your hardware. When done correctly, the tension breaks. The interface lights up, and you have a powered machine ready to ride. Getting to this point relies on 3 non-negotiable laws of alternative charging: strict voltage matching, a limited current flow, and correct polarity. Yet relying on these workarounds carries a hidden cost. Alternative chargers lack the ability to communicate perfectly with your scooter's specific battery management system. Over time, this lack of precise communication causes the individual cells inside the battery pack to charge unevenly. This cell imbalance permanently degrades the battery's total lifespan and riding range. These 3 methods provide vital emergency bridges to get you home safely. However, to guarantee the long-term survival of your scooter, your ultimate goal must always be replacing the original manufacturer's charger.